Good evening. Welcome to this impressively packed lecture theatre. My name is Vice Principal Professor Jeff Haywood. It's my pleasure to host this inaugural lecture this evening. And I must say the size of the audience is really a remarkable tribute to Simon Kirby's pulling power, as they say. We've just edited the blackboard behind us because we decided it might distract you slightly, trying to work out the relationship between sex, art and sciences and admissions. You might think about that for a short while if there's a dull moment while Simon's talking. Simon was born in England, spent most of his time in Scotland, came here as a student in 1988, and my quick finger arithmetic tells me that he's been here for 21 years, which is, he's doing remarkably well, considering that length of time. Became postdoc, a PhD here in linguistics, and then to postdoctoral positions, lectureship, reader, and now to a personal chair as Professor of Language Evolution. He co-founded the Language Evolution and Computational Research Unit, which is now the world's largest group of researchers looking at the origins and the evolution of human language, and he's been director of the graduate school in philosophy, psychology and language sciences. Simon's research looks at the origins and evolution of human language as well as cultural evolution more generally, and he's pioneered computer simulation as well as laboratory experimentation to tackle questions in language learning and change and in evolution, and particularly developed the iterative learning model of cultural evolution. Simon's at pains to remind me that he matches his academic activity with an artistic, a very strong artistic bent. He's been involved in the Found Collective, producing interactive artworks, exploring issues relating to culture and communications in a densely connected world. Not surprisingly, his research and his artistic achievements have attracted worldwide coverage, New York Times, New Scientist, as well as the BBC's Horizon programme series. And in 1929, with the Found Collective, he won the Scottish BAFTA for the Best Interactive from Cyberphon, which graced the InSpace building in informatics to the amusement of many of us for several months. His latest installation is actually now in InSpace at the end of the road across on the other side. In addition to all of that, he's also a DJ. Doesn't say what kind of music. He's a DJ at a monthly live music event, and then the little time that I'm sure, the tiny amount of time he's got left, he devotes to his family. We've got several members of his family here in the audience, and we welcome them. Unfortunately, Simon's father was unable to be with us, and so we are videoing the event, so you should be conscious that we are videoing so that he can watch it on DVD later. I have great pleasure, and I hope you will join me in welcoming Professor Simon Kirby to give his inaugural lecture on language, I have to read this, language organism, evolution, culture, and what it means to be human. Simon.
Thank you very much, and thank you all for coming. It's great to see so many different kinds of faces here. It's a very unusual mix of people to talk to in one of these events. And I just wanted to start by getting us to think about what an extraordinary thing it is we're doing right now. And by that I don't mean listening to me give an inaugural lecture, although you might think that's extraordinary. More that what we're actually doing right this second is pretty incredible. Basically, at the moment, what I'm doing is taking a thought that's in my head, or a series of thoughts that are in my head, and causing all of you to think them as well, or at least think very similar thoughts. And I'm doing this in a matter of a few seconds. I'm able to do this trick. And the way I'm doing it is by breathing out very, very slowly through my mouth while moving around my tongue, my jaw, my velum, and my vocal folds in an incredibly intricate dance of coordinated complexity. And I do this really without thinking, thankfully. And yet, by doing this thing, you are all able to think the same things that I'm thinking. And that's despite actually some of you I've maybe not even met before. So I've not met you before, and yet you're able to understand what I'm doing, this weird thing, breathing past a moving tongue. So that's a pretty incredible trait, and a pretty incredible trick. And I think that's the real thing that I think is very special about language, and that's why I wanted to study language, is to try and work out how we do this. And the other thing that's perhaps even more extraordinary about this trick is that we're able to do it with thoughts that we've never expressed before. And not only that we've never expressed before, but have never been expressed before in the history of our species. So for example, I can say, let me think, 48 pigeons just escaped from the International Space Station, right? Now, I'm pretty confident no one has ever expressed that thought before. No one has ever said those string of sounds before, and yet I think probably all of you had an image in your head that's somewhat similar to the one I intended to convey. So a very, very clever trick. But what's perhaps even more extraordinary about this trick is that we are the only species to do it. This thing that we're doing now defines us as a species more than anything else. Now, that doesn't mean that communication doesn't exist elsewhere in nature. In fact, it's widespread. In fact, arguably, all living species communicate. So here's a picture of a vervet monkey listening to an alarm call, a primrose as seen under ultraviolet light. That's how a primrose would look if you were a bee. And here is a Staphylococcus bacteria communicating to form a biofilm. All of these species are communicating. So we have millions of examples of species that communicate, but no other species other than us can do this trick that I mentioned. No other species can go beyond a pre-specified set of messages to communicate. That's our trick. That's what we do. So how do we do this? Well, this is mainly an excuse to show a really cute picture of my son's Converse from when he was little. But roughly speaking, the fundamental trick that language has is being made up of parts. It's very simple, really. The way in which a sound that I might make, like two boots, could convey an image like this is because it's made up of, firstly, it's made up of meaningless units that we can recombine in different ways. We call them phonemes. And then those recombined units are themselves combined together as meaningful units. We call them words or morphemes. So the sound two boots is broken down into these bits, and those bits are recombined to make words, and those themselves are recombined in various ways to make whole meanings. And it's the ability to take these parts in language and recombine them, put them in different orders, resort them, that allows us to talk about things that we've never talked about before. And if we're in a particular kind of community with certain kinds of social ties with each other and a shared history, because of the virtue of the ways of talking that we've learned, I can be confident that everyone in this room will understand me when I do this. So these are to some extent, these are the most basic facts about human language. And we might call them, if we wanted to be technical, something like phonemic coding, compositional syntax. So they're very, very fundamental. In fact, they're so fundamental, you almost don't really think about them. You don't think about them as something complicated or something very interesting to explain, or some people do. We teach them probably in the first lecture, or at least in the first week of our Linguistics 1 course. We tell students about this kind of self-evident fact about language. And it's this trick, these two tricks together, that allow us to do this species-defining thing. But I'll let you into a secret. We essentially don't know how we came to have these species-defining traits. We're trying to find out, and that's the job of my research group, as far as I see it anyway, but we don't really know. This foundational structural core of linguistics, we have very little idea of where it came from and why we have it. So that's what this talk is about. Where does this language structure come from? So obviously people have thought about this and tried to answer this question. And when you think about language and you think about language structure, this unique feature of our species, two kind of things might jump out at you about it. Two important things, truisms. Firstly, it's universal, okay? So whether you're one of the 20 remaining native speakers of Manchu that can read the written form of the language, or whether you're a speaker or a signer of the world's youngest language, this is Nicaraguan Sign Language here, only a few decades old, or whether you're a student texting in a class with one of the most diversely spread languages, English. All of these languages share these two fundamental properties. So this property of recombining meaningless elements to make meaningful elements that are themselves recombined. So it's universal. It's a universal trait of our species. Secondly, it's a hugely adaptive trait. So this is a photo of the Earth seen from space. And obviously the thing that's striking about this, it's the Earth at night. And you can see how extraordinarily widespread our species is. But more so, we've not only spread around into pretty much all habitats. This photo could have, I don't think this one was, but this photo could have been taken from the International Space Station where humans have been living for a decade, right? So we have spread to a ridiculous number of diverse range of habitats. And it's very hard to imagine how we could do this, how we could go into space and take a photo like this if we didn't have language. Because what language provides us a way of essentially networking our intellects and developing things like cumulative culture and civilization and technology and so on. So language is a massively adaptive trait. It's allowed us to outcompete our fellow species by quite terrifying extent. Yay us. So we've got these two traits, two features of language, that has its basic structure is universally shared amongst our species, and it's very adaptive. So what's a reasonable place to look for an answer for where these structural properties come from? Well, the obvious one that springs to mind, I think, is to look where you would look for any other adaptive feature of a species. And that's to look to Charles Darwin and try and find a Darwinian explanation. So perhaps language is just like any other adaptive feature of some organism's biology, like the heart or like a bat's echolocation or whatever. It's a trait that we have that we got by evolution by natural selection. So this is a slightly different trait to the heart. It's not, you can't sort of pull it out of a body and look at it. It's a feature, presumably, under this account of our cognitive makeup. It's part of our brains in some way. Some people have used the analogy of the language organ that's somehow sitting inside our skulls. So this is an innate feature of our species' cognitive makeup. That is, that we're born with it. It's part of our biological heritage. And if we have this biological organ that's also adaptive, it seems reasonable to suggest that it evolved by natural selection under pressure for improved communication, for example. So that seems like a reasonable way to go to try and understand the origins of language. So job done, maybe? Well, actually, back 21 odd years ago, 20 years ago, whatever, when I started sitting in as a student on a course by Jim Herford, when I was an undergraduate, it seemed like this was the obvious answer, that basically what we would want to do is just cross the T's, dot the I's on this kind of explanation, and then we would understand where language came from. 21 years later, things look very, very different, and that's what I'm going to tell you about. And the reason they look different is mainly because of the work that Jim started in earnest in the late 1980s. And I think what it's done is really changed our view of how to explain these properties of human language in a very exciting and interesting way. And that's what I'm engaged in. So why? Let's think about why we might not be satisfied with the standard explanation. Well, there's another unusual feature of language, other than just its structure. And that's the fact that any capacity for language that we have is a capacity for learning language. It's not that we're born with English or any other particular language. We're born with some capacity, it seems, for learning language. So any kind of innate component of language must just be something that stops language being useless, right? It maybe constrains us to only learn in a certain way that will give us these two properties that we were talking about earlier. So that's not so unusual. You can certainly find other species who have particular predispositions for learning certain kinds of things. So that's not particularly unusual in itself. But something that I've sort of come to be a bit obsessed about, actually, is that I think that language learning and maybe a handful of other examples are a very interesting and unique kind of learning in nature. And it's something that I've termed, or my student actually, termed, we argue about who termed this first, Henry and I, but I think it was him. Anyway, we termed it iterated learning. And so iterated learning happens whenever we learn from others, okay, and those others learned in a similar way. So the behavior that we're learning when we're learning language is being produced by people who themselves learned language from other people, who themselves learned language from other people, and so on, back through history. And this is what we call iterated learning. And in other words, anything that's passed on by iterated learning is something that's transmitted culturally, okay? So it's part of cultural transmission, language is. And it turns out that it's very hard to find other examples of iterated learning in nature. We may have time to talk about one, obvious one. But this makes language a very, very unusual behavior indeed. And I think what we've been tackling in Edinburgh in my research group is to try and understand the implications of this fact that language is transmitted this way, because we think it changes everything. So the idea is that the fact that language is transmitted by iterated learning essentially creates a new kind of evolutionary system that sits on top of the biological evolutionary system that we're familiar with. So this is the sort of view of, sort of sketched view of how biological evolution might work for language. So we have some set of genes that are passed on and inherited, and those genes give rise to some faculty in our heads about there that allows us to learn language. So that's the kind of traditional view. And obviously, things happen here like mutation and natural selection and so on that make this trait of or feature of our brains evolve over time. But what we add to this is this other system that sits on top of it, right? So here we can imagine this brain, here's some people talking, and that influences whatever the state of their brain is, right? That's learning language. And then later on, that brain goes on to talk itself, and then that influences the state of another brain, and so on over time. So we inherit our language through these two channels. We inherit the mechanisms for learning language genetically, and we inherit the languages themselves culturally. So, right, well, big deal. That's pretty obvious. And, you know, though any of you in the audience who are interested in historical linguistics or language change and so on go, yeah, we know this, right? It's a very, very long tradition of looking at language change. And sure, language change works like that. It has to work like that, right? But what we've been arguing is that this kind of cultural process isn't just going to tell us something about language change. It might also tell us about how language got going in the first place, how we could get these basic features of language out of nothing, how we could get language evolution proper, if you like, language out of no language, which is what we're interested in. So could this new evolutionary system provide an alternative explanation, an alternative to the biological explanation for language evolution? Well, to answer that question, we need to find some way of studying language evolution, and that seems already a bit of a problem. How on earth can we study language evolution? So evolutionarily ancient early forms of language that existed in our proto-human ancestors won't have left any fossil remains, at least not directly. So this is a picture of a Neanderthal hyoid bone, and the hyoid bone is implicated in the apparatus that holds and moves the tongue. So some people have said, well, yeah, we can look at things like this, right, this fossil hyoid bone. But there's all sorts of difficulties in interpreting these kinds of real fossils. So, for example, the fact that this Neanderthal hyoid looks very like a human hyoid made one group of people argue, well, this means that Neanderthals had a certain shape of shape of vocal tract that meant that they were very similar to humans and therefore they spoke. And then another group of people said, actually, no, you can't tell anything about the shape of the vocal tract from the shape of the hyoid bone, and arguments rage. Okay, so all we've been left with is apparently these tiny pieces of archaeological evidence. Very important if there's any archaeologists in the room. But we would love to be able to get at the real thing, the behaviour itself, and we just can't do that. It doesn't fossilise. And most of the evolution that we observe now, we're observing in historical change between languages that are already full human languages. Okay, so we can look at the historical evolution, if you like, of English. But of course, Old English was just as much a language with these properties I've been talking about as modern English is. So that's interesting as well, but it's still not telling us where these basic features, this sort of combinatoriality and compositionality of language came from. Where did the structure come from? So what we have proposed in Edinburgh is a new approach to this, to try and actually study the emergence of these features of language in the laboratory with real human subjects. So this is my research assistant, Hannah, posing for a very posed photo of an experiment we might be doing with one of our PhD students. But the idea is that maybe we can recreate in miniature the evolutionary process in the lab. So can we create cultural evolution in the psychology lab? It seems like a ridiculous thing to try in a way, but we figured that we can do this in miniature. And then the question is whether the things that we learn in a miniature toy system can tell us much about the big system. And well, we'll see. So what we decided to do was try and recreate this process of cultural transmission of language with whole languages. So the thing that we're doing is rather like the game of Chinese whispers, where I whisper a sentence into Jeff's ear, and Jeff whispers it into Christina's ear, and Christina whispers it into Hannah's ear, and so on. And the fun thing about that is as the sentence is passed through the crowd, you're the crowd, sorry, through the attentive audience, is the interesting thing about that game, which makes it fun, is that the sentence changes. And it doesn't just change randomly. It's shaped somehow by being washed through the brains of all the people in the room. So as that sentence in that game passes on and you hear the end result and you have a good chuckle, because it's revealing something about the brains of the people it's passed through. So the sentence has evolved as it's passed through by Chinese whispers, and it's evolved because of the brains it's passed through. So what we thought was, well, let's just do that game, but do it with whole languages. So what we do is we basically get people into the experiment lab and we get them to learn a miniature, what we call alien language. It's a scam to get people to come in to do our experiment when we tell them they're going to learn an alien language. It's actually a language initially made up by a computer program that just generates random strings of syllables or various other things. So it's a language that we've given them. So the people come in and learn that language, and then we test them after they've done their learning period. As you can see already, it's not as fun as Chinese whispers in real life. We test them on it, and then they leave. And the trick, there's nothing particularly clever about these two steps. Lots of people have been doing these kind of experiments in psychology for a while. But our trick is to take the output of the participant when tested and use that output as the new language to train the next person who comes into the lab. And then we repeat that process. So we can inject a language at the start of this chain of people and then just watch as it changes as more people learn and produce over time and see what happens. So in that way, what we're trying to do is recreate this cultural evolutionary process in a timescale that we can get funding for. So just to give a little bit more, I can't go into much detail here, but a little more detail about the kind of things we do. So we've had, here's 2 example setups for experiments that we run. So we wanted to see if we could get that feature I talked about of the little elements, meaningless elements that recombine. So we started with a language, in scare quotes, with no component parts at all. And the way we did that is we got people to listen to slide whistle noises, like a swanee whistle. And they were just random, right? And then we said, okay, learn these, and then recreate them on a slide whistle that we'll provide you. And then we take their output and then train the next person on that, right? Pretty straightforward. And what we were looking for in that experiment is to see if what we get out is little elements that are recombined and reordered in different ways. So that's one kind of experiment that we do here. Another experiment, we say, well, let's assume that we've got those recombinable, meaningless elements and start with a language that has those in place, but doesn't have any of those meaningful elements like words, and see if those emerge. So the kinds of things we do here is we get people to learn these weird names for these strange alien amoeba in the lab. There's puzzled faces of participants. It's hilarious. But basically, so you will see an amoeba like that and have to learn this word for it. And there'll be a whole set of these. And the important point is, let's say in this second example, we get the computer to generate these names for these amoeba at random. So there's no parts in this. It's just a string of random syllables. And so they have to just learn them all by rote. Okay. So what happens? So just looking at that experiment, for example. So at first, our participants find this task just basically impossible. In fact, often our participants will get every single one of them wrong. So they just don't remember anything. And when we first ran this many years ago, we were a little worried about that. We thought, wow, yeah, this isn't any good, getting a score of 0 on this task. But the remarkable thing is that over time, as new people come into the lab, they get better and better at the task. And by the end, in some cases, our participants learn the language very easily. They say it's a really easy problem. It's not hard at all. So over time, the languages are changing. The people aren't changing. It's not like we're getting more evolved participants late in our experiment. Rather, the languages themselves are being changed by this cultural evolutionary process. And what seems to be happening is that the mistakes people make in this task are changing the language, but they're changing in a direction that makes it easier for future generations to learn. So the language evolves culturally. So this is just because I wanted to show new data. This is data from an experiment that's underway at the moment. It's unpublished. Ooh, exciting. Right. So, but over time, the languages get easier to learn. So how are they doing that? What happens to the language that makes them get easier? Well, as I say, first off, people find the task impossible, but it gets easier over time. This is the sort of thing that this is just a subset of the language, a small part of the initial random language that for one of our experiments. So there's many more amoeba than this, but even with this, you can see if I asked you to remember quickly all 4 of these names and then I tested you, I bet you wouldn't get very many of them spot on. I could even cover one of those up and then say, what's the name for the black one in the top left? And if I'd covered that over, I think you wouldn't have been able to remember it. So that's what it looks like at the start. But later on, this is, I think, 6 generations later in that experiment, this is what it looks like. And I've coloured these to make it clearer to you what's going on. And what we see here is that things have changed. So, for example, in this particular experiment, this part, this gala, seems to refer to the shape of the amoeba. And guru refers to this. And then the first part of the word, the string, whatever the expression, the name, seems to refer to the texture in the center of the amoeba. So Nella means spotty, for example. Now, that's just emerged, and it's not that anyone's sat down and invented this. This happens gradually, and none of our participants think they're doing anything. They think they're just giving us back what we trained them on. And in fact, our most recent experiments confirm what I've decided to call the fresh brains hypothesis. What seems to be needed for language to evolve like this is, and get easier to learn and more structured, is for new people to come in and learn it. And I think that's what's absolutely crucial about language evolution. So why is this happening? Well, it's, as I said, it's hard to learn a language that doesn't have any structure, and it's much easier to learn one that has these reusable parts. There's less to remember. And this iterated learning process guarantees that the language will become more learnable over time. And one way to think about this is to sort of turn things on their head and think, rather than thinking about us being adapted for language biologically, rather language is adapted to best survive in us. In order for language to be passed on and to work, it has to be learnable by children. And that is the adaptive force at work in the explanation of these structural features. And this has led a number of researchers to suggest that language itself can be seen as an organism whose environment is our brains. Whether you can really make that analogy work, I'm not so sure, but it's highlighting the point that you can look at language from this other perspective and understand features of it. So we argue that this thinking about language as a cultural evolving system is the right way to go. But people who argue for the alternative perspective say, well, okay, you've shown a mechanism that gets language structure by cultural evolution, but that doesn't rule out the alternative explanation. I mean, it just gives you another tool, another possible explanation. It doesn't rule out the fact that biology actually did all the work. So what we wanted to do is to test what would happen if you have both of these processes running at the same time. Because really, if we want to understand language, and this is something that Jim Herford has explained very clearly to us in that class 20 years ago, you have to understand that it operates on these different domains and these different timescales simultaneously, and there may be interactions between them. So we have to think of it as a cultural process and a biological one. So what we really want to do is see cultural evolution happening and biological evolution happening at the same time. Now, we can't do this in the lab. It's unethical to selectively breed participants, and it would take too long. So what we've had to do is use computer simulation instead. So we essentially replace those real squishy chemical and human parts of the previous setup and replace them with hard digital robotic components. This is a Sony Curio robot, and it's not just gratuitous that that's there, because some groups actually have used the Sony Curio robot in part of these experiments, so groups in Paris and Brussels. We neither can afford one of those nor think it's actually necessary to do it in robotic models, but it's interesting that people are trying. So we use computer simulation. So we have simulated sets of genes that determine some innate learning preference of our computer people, or not, as the case may be. And we have these simulated computer learners what are called in this field agents for some reason. So we have these simulated agents communicating and learning from each other in the computer model. And the agents survive and pass on their genes if they're good at communicating with each other, right? So the language in these simulations is passed on just as it was in our experiments in the lab, and the genes are passed on in a very close analogue to biological evolution. So we can, in the matter of about an afternoon, run thousands and thousands of generations of simulated population of a simulated population of individuals communicating and mating and reproducing and so on, and to see how these two evolving systems interact. So what might happen? What should we expect? Well, a lot of people have looked at these kinds of models and this kind of situation and said, well, what we should expect is if these universal features of language, these language universals, emerge culturally, then, and you've got natural selection for good communicators, what should happen is that you should start off getting these properties through cultural transmission, cultural evolution, and then you should get genes that make you learn that better and better and better. And in effect, what you should get is things starting off in culture and then gradually moving over into the genes in a process called nativization. So what we should expect, according to a number of people who've argued this, is that we should simply expect to get those innate language universals that we talked about before. So we should expect to have these agents having brains that are set up to learn the specific languages and the language structures that we get. The surprise is, and this is work that we're doing right now with my colleagues Bill Thompson and Kenny Smith, is this doesn't happen. And this was a surprise to us, and we were delighted. We don't end up in these models with the agents having the language encoded innately. And the reason for that is, firstly, very complicated, and secondly, we don't totally understand it yet. This, again, is not published work. But what seems to happen is that somehow culture is shielding us from the view, if you like, of natural selection. So instead of having the genes determining the way our brains work, once we have culture around, what happens is that culture takes over the load of creating useful behaviours. And that actually lifts the selection pressure off our brains. And what we have is that language is adapting so well that any slight preference of our genes is enough. So there's no difference between someone who's born knowing all of language already or someone who's born with only slight predispositions towards the language structure that we see universally. It makes no difference. And so that means that variation in our genes in these models are effectively masked from the view of natural selection. And we're just now working out the implications of this. But what it seems to suggest to me very strongly is that we should reject the idea that's been around for a long time that we have an innate, strongly determining capacity for language. So the take-home lesson from this is that the existence of culture radically changes the way biological evolution works in our species, and strong innate universals are highly unlikely for evolutionary reasons. So, what's left for biology? I mean, this is a horrible example that people will groan at, but my pet cat never learnt to talk, even though she was around about the same time and in the same situations that my son was, and he's learnt to talk and talk and talk. So there's got to be something that's happening in our biology, right? There's got to be some difference. And we are special, as I said before. Why are we special? what's left for biology to explain? Well, I think the place we should be looking to biology for an explanation is how we even got this cultural evolutionary process off the ground to start with. And when I look at that, and when I look at our models and our experiments, it seems that we have to build in a couple of things to make it work, right? We have to build in the learning of signals. So this is one thing that we do. Now other species do this too. We learn complex signals, so do birds, so do bats, so do whales, and a few other species, perhaps elephants, but not that many. We're one of them. We're the only primate that does this. We're the only primate that learns to produce signals from other producers of signals. So that's something that we do that's unusual. And we need that in order to get this cultural transmission process off the ground at all. The other thing that we do that's unusual is that we have a predisposition and a capacity for sharing meanings. Now this is, I had to pack an awful lot into 2 words here. So this is a little bit vague, but sharing meanings is something that our species does that's, again, very unusual. It's not, so the sort of things that we can do that birds, for example, are absolutely hopeless at, is that we care about what other people are attending to, for example. We follow pointing. There's a bunch of things that we do that seem to be about having the predisposition and capability of sharing meanings, and that's extremely important. Interestingly, dogs seem to have a lot of these as well, and that leads me on to the next slide. So these two things, I think, are what we should be looking for biological evolution to provide us with. And I think once we have both of those, and perhaps we are the only species that has both of these, then the cultural process can do the rest of the work for us. So in my abstract, I said that we'd learned something from foxes, so I have to put this slide in. If we look for similar traits in other species, this is a picture of a very unusual fox. This is a Siberian fox that has been bred for lack of aggression as part of an experiment that has been going on for, I guess, maybe it's 40 years or so now. These foxes were simply bred to be approached by humans. Basically, the experimenters would walk towards the foxes and measure the distance before they got scarily aggressive, and then just basically breed the ones that they could get closer to. And what's surprising about these foxes in this farm fox experiment is that these foxes ended up being able to learn social cues like pointing, which are very familiar in dogs, but no other foxes do this. And these Siberian foxes at no point in their evolutionary past ever had this kind of trait. So just by breeding for lack of aggression, these foxes ended up reading social cues and learning social cues. That's kind of interesting. The other example I think is very interesting and suggestive, this one. This is a Bengalese finch, and this is a white-backed munia. These two birds are separated by about 300 years of selective breeding for plumage. So the Japanese breeders bred the Bengalese finch just to have nice feathers. And yet the amazing thing when researchers looked at these two birds is that they differ in their complexity of their learned song. So these domesticated birds learn very, very elaborate song with really interesting syntactic properties for a bird, compared to the very simple song of their wild equivalent. So perhaps there's something to be looked at in domestication. These two species seem to have got radically different traits just through a process of domestication. So this is where speculation alert. I promised Chrissy I would show a slide with some fire on it. So this is where it gets speculative, but this is where I would look to try and find the answer to why we uniquely have this capacity for cultural evolution. It seems that domestication might lift the selection pressure on an evolving species, and it seems that might have been a necessary step for traits of language to emerge. So am I suggesting that humans are domesticated? Well, maybe they are. Maybe we are. It's interesting that if you look at a textbook on domestication, one of the things that seems to be very clear is there are a key set of traits that a domesticated species has. Now, this isn't my area at all, and there may be people in the audience who know an awful lot more about this than I do, unfortunately. But the three things that you read about are things like reduced teeth size, decreased skeletal robustness, craniofacial shortening. And this is a skull of a human and a skull of another hominid. This is a gorilla. So we seem to show these key traits of domestication. So perhaps what's happened at some point in our past is that we domesticated ourselves. And perhaps this laid the foundation for cultural evolution. Now, there's a lot of perhapses here. And this is not something I can tell you this has definitively happened, but my PhD student, James Thomas, is looking at this kind of hypothesis. And one of the things we want to do is do some more computational modeling to try and understand whether this kind of thing could be enough to give us language. Okay, just so to conclude, where does language come from? Well, it comes out of a very, very interesting and unique mess of different systems in our species. So we have biological evolution. We have to look at that in order to understand language. We also have individual learning. So we all learned our language from our parents and other people around us. And that gives rise to cultural transmission. So language is transmitted over time. And out of all three of these interacting, language emerged. And if we're to try and understand the evolution of language, then we've got to understand the impact on biology of individual learning and culture. And I think that what we're finding out now, and when I say now, I mean right now, is that culture seems to be radically altering the way we as a species adapt. And we have given rise to a new kind of evolutionary system by virtue of having language. Okay, now just before we finish, one last thing I wanted to talk about. Some people might have wondered what Jeff was talking about in the introduction when he mentioned art. And some other people might have been wondering what I do on a Wednesday afternoon on the ground floor of the Dougal Stewart building in a funny little room with some strange contraptions in it. One of the things I'm incredibly fortunate to have had in my time in Edinburgh is a fantastic research group, the Language Evolution and Computation Research Group. But I've been doubly lucky because I've also been really lucky to have fallen in with a art collective, the Found Collective, who are also, they're also a famous band. They didn't let me in the band, very sensible. But I'm part of the wider collective, that's what they like to tell me. And what we've been doing is over the last, I guess, 5 years or so, have been building interactive artworks. And one of the things I wondered when I was planning this lecture is whether I could give you a hint of why I think that there is a connection between that stuff that we do and the stuff I've been talking about today. One of the things I've learned from doing that is that really art and science, they're very, very different, but in fact they have something strikingly common in the practice of doing them. And that's that they really provide different ways of tackling the similar kinds of issues. And you can ask similar kinds of questions when you are doing both. So there are different ways of exploring similar issues. And the kinds of issues that we've been talking about a lot in my research group, especially recently, obviously is how information is transmitted between individuals and how it evolves through that transmission. And also I have students doing work on things like social networks and the role of social networks and the way we interact as a sort of matrix on which this cultural evolution takes place. And that's also, those are the same kind of issues that I've been trying to tackle with Found, with these funny machines. Like this is our narcissistic, social media obsessed, interactive, autonomous robot band. And this is a machine that if anyone's interested, you can go across the road and have a play with. This is a machine that remembers everything. The idea behind these is to think about what it means to be a human now, essentially. If you think about this kind of the way information is being transmitted and evolves between individuals, you can think in our human history there have been a number of revolutions, in historical time, revolutions in the way this has happened. So you can think about agriculture, the emergence of writing and literacy. Urbanization obviously radically changed the way our social networks were made up. Globalization would be another one. And I think now it's not too extreme to think that we're possibly in undergoing another similar kind of revolution right now in an age of Google and Facebook and Twitter. We seem to be in the midst of a new and rather radical and rapid shift in the way in which our social universe is configured. And we're essentially offloading the job of constructing social networks to a set of machines that have access to algorithms and data that we couldn't hope to deal with by hand. So the people that you know and you interact with, if you're a part of one of these online social networks, those people have been set up for you by machines, not by yourself. And and the way in which we deal with that interaction is something that I'm very interested in, because I don't think we really understand these new spaces that we've built. And watching the behavior that happens on them is something that's very interesting. Now, obviously, people are doing science in that realm. And I'm not saying that I am doing a sort of scientific study of that. But what we're trying to do with Found is create machines that embody these new realities in as an absurd a way as possible. And by doing that, I hope, and also the other work that I've talked about, I hope we can possibly eventually shed light on what it means to be the kind of fascinating, unique, and infinitely flexible species that we are today. Thank you. A couple of questions?
Simon said that he's happy to take a few questions. Simon, can you remember to repeat the questions so that we capture it for the
If there are any, obviously.
if there are any, yeah. Make them repeatable by him.
Anyone? Yeah. Well, certainly it has merit. I mean, apart from anything else, it obviously has. Repeating the question. So the question was about the growing body of evidence and research looking at the genetic bases for specific language disorders and impairments. Now, that would appear to provide evidence for a genetic basis for language, but our work isn't ruling out a genetic basis or genetic support for language. What we think our models show is that we shouldn't expect genes that have adapted to strongly constrain the language structure. So the interesting thing is so apart from anything else, we would expect genetic adaptations to the support mechanisms that maybe help you process or use language. But we don't expect genes that strongly constrain the ways in which language is learned. So then when you find genetic disorders that affect language learning specifically, then that's a challenge to that. The difficulty is teasing apart what happens if, say, you have a specific language impairment that affects processing, affects social interaction, affects all sorts of other things that are absolutely crucial for the acquisition of language. Do you know that those genes are there specifically for learning language structure, or are they in fact knocking out a whole suite of behaviours that are needed to acquire language in the first place? And that's the tricky thing to untangle.
Thinking of your it's very linear and serial. And I would consider it more maybe appropriate for the genetic transfer than a cultural one. It's pass the parcel, I pass on, I die, and so on. One of the advantages of language is it's one to many, if it's possible. So you can have these sort of parallel paths, some of which will come back and reinforce, some of which are divergent, and so on. And this sort of interaction, as is dialogue, you expect feedback and so on. So it's just this feed forward.
So the point is that language and a lot of other cultural traits aren't transmitted purely as this vertical pass the parcel is a good analogy. We're at the mercy of diagrams in talks like this, right? So and Chinese whispers is such a cute example that it can mislead. So in our simulations and now also in our experiments, we are very interested in comparing the effect of horizontal transmission with vertical transmission. So some of the experiments that we're doing now look at what happens when you have two individuals communicating backwards and forth in dialogue and changing the language as a process, and then new individuals coming in. And we compare the situation where there's just two people in a dyad communicating backwards and forwards for a long time versus the same situation where a new person is coming in. In simulation, we can look at real social networks, and we can see what happens as languages are transmitted over them. So we want to tease out the effects of horizontal and vertical transmission. So don't get the opinion that we only care about vertical. But one of the things, this is my fresh brains hypothesis, is it really does seem to matter. So something happens when a new mind enters, or a new brain enters the system. And it seems to have something to do with, and the discovery, I guess, although again it's not published yet, is that those new minds are required to get these structural properties to come in. And what seems to be matter is that you have individuals who only have access to a sort of top slice of the history of interaction of a group of people. The problem with a lot of experiments that just look at dyads interacting, for example, is that there's something very weird about that situation because both interactants remember everything that happened to them. And what's, I think, incredibly important about cultural transmission is that there's a point at which an individual has to only see a part of that interaction and then sort of, if you like, reconstruct the rest. And it's in that reconstructing process that these magical things happen. So, yeah.
Alien language experiments being done in different parts of the world, and would you expect different results depending on the native language that you're doing?
They have been done in different parts of the world, but they've all been done with people who, as far as I know, who's have English, if not their native language, and know English well. Now, obviously, well, maybe it's not obvious, but we do expect there to be an effect of your native language. You're not going to be able to partial that out. And it's a deep problem with doing these kind of experiments that our participants are already language users, right? And they're already evolved modern humans. But I'm quite sanguine about that because we also back this up with the computer model where we know those computer agents don't have a particular language. So you have to tackle these kind of challenges on multiple fronts. And it's only by showing that the predictions that we get from the computer model are borne out in the lab experiment, and the lab experiment can inform new computer models, that we can get around the possible objection that all we're getting back is the structure of English. Aside from that, though, it certainly doesn't look like the structure of English that we get out. Yeah.
In your wild speculations, when you talk about domestication, I really wonder what you mean by it, because when you use domestication as both the process of getting foxes less aggressive and changing the plumage color of finches, then this is very strong direct towards selection, and it's not really freeing any organism from natural selection, putting a strong...
Yeah. No, that's a very, very good point. So the point there is that in the case of the farm fox experiment and in the breeding of the Bengalese finch, there was very strong selection. The selection was coming from the breeders. That's a very good point. And you know, it's difficult to know what exactly was going on. If our hunch is right, that self-domestication is a part of our story, exactly how that would happen is unclear. And personally, I think that we're probably still doing it. I think I'm more domesticated, as my than possibly I would have been if I was growing up 1,000 years ago. I think the technology we create, it acts to domesticate us even further. And so what I'm meaning by domestication here is essentially just a buffering away from the sort of pure survival pressures that natural selection is placing on these species. So what's happening in the Bengalese finch example appears to be that the wild type has all of these other things that it's got to worry about. That means that it doesn't have the space to have these elaborate song. So things that it's got to care about are things like being identified as conspecific by potential mates and avoiding being eaten by predators. Whereas the bird that's being bred for plumage, it doesn't have any of those worries. So those selection pressures are taken off. So I think that there was probably a lifting of a whole raft of natural selection pressures at some point in our history that left space for these other things. And then there may well be a role for things like sexual selection or social selection or just being selected for being kind of nice. Rather than necessarily being very good at killing, big game or whatever that some of the other people have speculated, other researchers have speculated. Yeah. So you can tell me to stop.
If Chomsky's watched your DVD to put on the web soon, maybe, and you're discussing about language innateness, what would you say?
If I was Chomsky?
No. If he asked you about, language innateness, what would you say?
Interesting. So if Chomsky were in the room and he asked me about what would I say to him? Well, it actually might surprise you. I think he may. It looks like what I'm saying is that Chomsky is wrong. So Chomsky proposed this strongly constraining language acquisition device that essentially means that we can only learn the languages that have these structural properties. Now, obviously, I don't agree with that. But there's an awful lot of things that he's argued that seem very strange to people that I think may have been on the money. So one of the things that Chomsky's always been very wary about is explanations for natural selection for communication. He seems to never want to commit to any explanation like that. And ironically, unexpectedly, from my perspective, we think that might be right. And in other ways, I think if there are features of our cognitive makeup that constrain the structure of language, I think they're most likely to be completely random, arbitrary, what Gould called spandrels, rather than the result of adaptations. And Chomsky would agree with that. But he would completely disagree with me about the idea that cultural evolution's interesting at all, because I know because he's said so much. So the ghost of Chomsky can leave.
Those who wish to continue debating the finer points I'm sure can continue outside. I'd like to remind those of you who are invited that there's a reception across in David Hume Tower conference room afterwards. And I would like to thank Simon for a really stimulating lecture, and I'm sure that you'll join me in thanking him for that. Thank you.
This production is copyright the University of Edinburgh.